Okay, this will be worksheet 6, number 2. An Alaska gold nugget is dropped from the edge of a roof and observed to pass by a window, top to bottom a window, that's 2 meters tall, in 1/10 of a second. The question is, how far is the roof above the top of that window? And I say draw a good picture because this one can be a little tricky. All right, so let's do that. The situation. All right, here's the top of the building, and we're supposed to find a certain height. And somewhere down here, there's a window. I'll just draw it like this. There's a window. And that window is 2 meters tall. So 2 meters across. And this is the height we're looking for. What is the height? Well, maybe we could just go right directly to it. I doubt it, but let's see. If I want to know the height above the window, so I don't know anything about time, maybe equation 6, this is 6-2 by the way, maybe equation 6, Vy squared is equal to Vy0 squared minus 2GH could help us. Now, it's possible it could help us. Do we have Vy? Vy is the final velocity. Well, the key thing about this is that the final velocity for free falling from here to here, okay, is the initial velocity for transiting the window. So I'm going to write that here because that's a really important idea. It's going to make this into 2 problems actually. Vy for free fall is equal to Vy0 for window transit. Okay, so that's the initial velocity when it hits the window and then speeds up across these 2 meters. That initial velocity is the final velocity of free fall. So going back up to the original thing, I want to find h. All right, so h is equal to Vy squared minus Vy0 squared over 2g. So Vy in this expression is the initial velocity in this one, in going across the window. Vy0, oh, that's just nothing. We drop it. So this whole thing, the answer to the problem is Vy squared over 2 times g, 19.6. That'll be the answer to the problem. But it's not so trivial to get Vy. So again, Vy for the free falling is Vy0 for the window. So now this is like we have a problem number 1 here, and down here is problem number 2. We really need to solve problem number 2 to take care of problem number 1, which is this. Okay, so we need problem number 2. So problem number 2, we need to use y is equal to y0 plus Vy0t minus 1/2 gt squared. So in this case, we need to find the Vy0. So let's go ahead and solve that algebraically. Vy0 is equal to y minus y0 plus 1/2 gt squared all over t. I believe that would do it. All right, so let's see what we know about that. This is just for the window now. Problem number 2 is just for this 2 meter window. So the final position of the window, you could say, is minus 2. The initial position of the window, you could say, is 0, because that's how I start my problems at the initial position being 0. So y, the final position across here, is minus 2, and we're going to subtract off the initial position, which is 0, and then add 1/2 g 4.9 t squared. Oh, now what is the t? The t is 0.1 seconds. T is equal to 0.1 seconds for this problem. That's how long it takes to transit the 2 meters. So 0.1 squared is 0.01. 0.01, there it is, all over 0.1. All right, this is, let's plug it in, -2 plus 0.049 gives us, let's try that again. 4.9 times 0.01 obviously is 0.049. And then we're going to subtract 2. It gives us basically minus 1.95 meters per second. So that is Vy0. That's the velocity at this point. And now, let's see, we got to divide that by 0.1. I didn't do that. I didn't divide that 0.1 by 0.1. So this is really minus 19.5 meters per second. So there is Vy0 for this, and it's Vy for this problem up here. So now let's go ahead and solve the problem. Vy squared, 19.5, the final velocity for the first part of the problem, over 19.6. 19.5 squared divided by 19.6 gives us 19.4. That gives us 19.4 meters. And that is our final answer. That is the height of the top of the building falling down to here. Now, if you solve this with just, say, a constant velocity across here, your result is going to be very similar, but not correct. It was a little tougher. We had to break this up into 2 problems, with the final velocity of the first problem being the initial velocity of the second problem, where it continues to accelerate across here for 1/10 of a second. So there you go. Hope you enjoyed that one.